my name is Lauren, and today I will be explaining how to do the unit circle and its degrees. This is video part 1 of 3. Let's get started. First, I will explain units of angle measurement. Within the unit circle, there are 2 angles of measurement, degrees and radians. There are 360 total degrees within a circle, and there are 2 pi total radians within a circle, meaning one full rotation within a circle is 360 degrees, or 2 pi. To start off, let's discuss which quadrants within the unit circle are positive and negative. Here in quadrant 1, you can see that the x and y axis are both going in the positive direction. In quadrant 2, you can see that the y-axis is still going in the positive direction, although the x-axis is now going in the negative direction. In quadrant 3, you can see that both the x and y-axis are both going in the negative direction. In quadrant 4, you can see that the y is remaining in the negative direction, although x is now positive. Now that we know which quadrants are positive and negative along the x and y axis, let's get started on the degrees within this unit circle. We know that along the x-axis right here, the degree would be 0 due to the x-axis being along the horizontal line within a graph. Next, we can see that this shape right here creates a 90-degree angle, meaning this up here is 90 degrees. Next, we can see here that this line creates a full 180 degrees, meaning it is a flat line. Finally, we can see here that this rotation is 90 degrees, but split into 3. So we know that 90 times 3 is equal to 270. So this angle right here is 270 degrees. Finally, we know from the definition over here that a full rotation within a circle is 360 degrees. So we can put a slash 360 degrees due to this horizontal line being equal to either 0 or 360 degrees depending on the rotation you have gone. Now it is time to fill in the blanks. As you can see right here, this line is equal to 45 degrees due to it being half of 90. Now we can fill in all the corresponding 45-degree angles seen here on the red lines. As you can see here, we filled in 135 degrees, 225 degrees, and 315 degrees. All of these are corresponding angles to the 45 degrees. We can find these angles due to them corresponding to 45. So for each angle, we just add 45, and we will therefore get the next angle. Next, we can see this degree right here is a bit shy from 45, but a little bit further from 90. With this being said, we know that it is 60 degrees. Now that we know this is 60 degrees, we are able to fill out the corresponding 60-degree angles. The lines here in red are the corresponding 60-degree angles. As you can see, each angle increases by 60 degrees. As we go from 60 to 120 to 180 to 240 to 300 to 360, we are all increasing these angles by intervals of 60 degrees. Now that we have the 60-degree corresponding angles filled in, we can now fill in this angle right here. As you can see, this 90-degree angle is split into 3 sections, right here, here, and here. Since we know the 90-degree angle is split into 3, we can divide 90 by 3 and get 30 degrees. Now that we have this angle filled out as 30 degrees, we are able to increase by intervals of 30 and fill in all the corresponding 30-degree angles. All these lines in red are the 30-degree corresponding angles. As you can see here, the 30-degree angles increase in intervals of 30, meaning we go from 30 to 60 to 90 to 120 to 150 to 180, and continue around the circle in 30-degree intervals. As you can see here, each of these 30-degree corresponding angles are now filled in, meaning we have all the unit circle corresponding degrees filled in. That's it for part 1 of the unit circle. Stay tuned for part 2, which will be how to solve for radians of a unit circle.